I'm Anil Kumar, and in this video we will learn how to graph transformed cotangent function. Question here is, sketch graph of y equals to cot2x plus 1. Now as you know, cotangent of x is the ratio of cos x and sin x, right? So it really means that all the zeros of cotangent x are same as the zeros of cosine x, and all vertical asymptotes for cot x will be same as zeros of sin x, correct? What I'm trying to say here is, let us analyze the graph of cos x and sin x, and then we will sketch cotangent x, and after that we will sketch the transformed function which we need to sketch, right? So let us try to understand the whole process. Now, cos x is kind of like this, right? So I'm just sketching a part of it. Sin x is, so let us say these are the zeros, right? So we can always divide it into 4 equal parts. Let us say I'm sketching one wave which is from 0 to 2 pi, correct? So sine wave actually goes up, down, and then up, right? So that is the sine wave. So as you know, for cos function, the zeros are, these are the zeros, and for sine function, zeros are these three, right? So which is 0, this value is pi by 2, pi, 3 pi by 2, and 2 pi, correct? So what we see from here, that for cot, the zeros will be same as zeros of cosine x, right? So let's write down zeros for cot x. They are going to be same as that of cosine x, which are these points, right? Which are pi by 2, 3 pi by 2, odd multiples of pi by 2, right? So so they are pi by 2, 3 pi by 2, and 5 pi by 2, odd multiples of pi by 2, correct? So these are the zeros for cos x. So these zeros will be zeros for cotangent x, right? So zeros for cot x are same as zeros of cos x, correct? Now, what are the vertical asymptotes? Zeros of sin x will give us vertical asymptotes for cotangent, right? So vertical asymptotes for cos cotangent x will be equal to zeros of sin x, correct? Which are 0 pi, 2 pi, or n pi, correct? Which are 0 pi, 2 pi, and so on, correct? So these are the vertical asymptotes for cotangent x. So what I will do here is kind of sketch a cot x graph first, and then we will sketch the transformed function as is required for the given question, correct? So what we get here is that the zeros for cotangent function will be same as zeros of cosine function, right? Which are these. So these are the zeros for us alternately, correct? The vertical asymptotes are the zeros of sin x, which are 0 pi. So these are the vertical asymptotes, correct? So these are the vertical asymptotes. Let me draw these vertical asymptotes, which are zeros of sine, correct? So we got zeros and vertical asymptotes for our function cot x. Now, which part will be positive, which will be negative, we can really decide from the ratio. If cos is positive and sine is positive, then cotangent is positive, right? Positive divided by positive. So in this half, it is positive. Then in the half, I should say the quarter, between pi by 2 and pi, one is positive, the other one is negative, so it's going to be negative, correct? So the graph of cotangent x will be kind of like this. Do you see that? So that is how the graph of cot x, this is not cot2x plus 1, we're just discussing the graph of cotangent x will be like this, where the vertical asymptotes will be n pi, right, multiples of pi, correct, 2n pi, and the zeros are odd multiples of pi by 2, 3 pi by 2. Is it okay? So that is how it is going to be. This is cotangent x. Now let us look into the graph of y equals to cot 2x plus 1. We'll do it with transformation, right? So when we say that we need to sketch cot 2x plus 1, how is this graph transformed when you compare it with cotangent x? So horizontally, it has been compressed by a factor of half, correct? So there are two transformations here. The first one is compress horizontally by factor of half, and the second one is translate 1 unit up, right? Translate 1 unit up, right? So these two transformations will actually give you the graph for cot 2x plus 1. You get an idea, right? So now it is easy to sketch. Let us sketch it now. So we are going to sketch it now here. So let's rewrite the zeros and the vertical asymptotes, right? So for cot 2x plus 1, let's say cot 2x, we'll translate 1 unit up later. So for, cot 2x, zeros will be half multiplied by this, right? So it'll be pi by 2, 3 pi by 2, 5 pi by 2, all multiplied and so on, multiplied by half. That is pi by 4 and all, right? And the vertical asymptotes will be at 0, pi, 2 pi, and so on, times half, because these are horizontally placed, correct? So let's have a new graph here on which we'll now sketch cot 2x, right? So let me draw these lines here. So we are not working with the graph paper, so we'll do approximately, correct? So we have few lines here, and each we'll put this as pi by 4, half times this, correct? So we'll have this as, let us say, pi by 4. So that is going to be a 0, right? So 0 is going to be a vertical asymptote. So let me sketch a vertical asymptote. Let me sketch a vertical asymptote here. Then we have a 0. Half of pi is pi by 2. So at pi by 2, we'll have a vertical asymptote. So alternately, we'll have vertical asymptotes and zeros, right, as expected, correct? So this is 0. This is pi by 2. And then 3 pi by 4 will be a 0. And then we'll have a vertical asymptote at pi, a 0, and then again a vertical asymptote, and so on. You get the idea, right? So that is one thing. So horizontally, these zeros are placed like this. Now all these zeros have to be shifted 1 unit up, since we have cotangent 2x plus 1, right? So that is the 1 unit up translation. So what I will do here is, I'll so we have this represents x for us. This represents the function cot 2x plus 1, correct? So now what we will do here is, we'll translate all these zeros 1 unit up and sketch our function, correct? So the graph which was going through the intercept here and had a 0 value, it will have 1 value at that point, correct? So the graph will be kind of like this. So instead of having it goes like this. Do you see that? So this is cot 2x plus 1. Do you get an idea, right? So what we have done here is that we have changed kind of the scale, right? So that becomes the graph for the required function cot2x plus 1. We have very few videos on cotangent x, and therefore I took time to explain you all these concepts. I hope with this you get a complete picture of how to sketch cotangent functions. Now with that in mind, you can actually sketch any transformed cotangent function. The trick here is identify zeros and vertical asymptote of cotangent function and then apply the transformations, correct? So once you have the transformations in place, the graph is clear. I hope that really helps. I'm Anil Kumar. You can subscribe and share my videos. Thank you and all the best.